Okay, let's get back to this scope thing and get into the more interesting things, and that is taking a look at that signal, zeroing into the detail that we want to see. We understand what a scope is, what it does. We're going to show you the horizontal or the time-based element of the signal and the vertical or the voltage-based element of the signal, and look into it. That's where we're going to spend most of our time. Just as a quick review, I have a link up here to Tektronix's explanation of the scope, because it's really nice to, at some level, understand how the scope operates. And they have a nice oscilloscope basics. It runs through here, shows you pictures, talks about all how things work behind the scenes, and I would take a look at that. There's a link up here, and you can get that. The second reminder is there is a Waveforms reference manual, which is a software that we'll be using for the Analog Discovery 2 scope. And there's a section in there that's more of a reference. You have to know a little bit until you're there, so you're going to have to play a little bit. But boy, when you want to find something, if you know a little bit and you know some of the terminology, come back to here. That's where it is. So those are the two things that are helpful. I've already started the software. And let's go to the waveform generator. And we tried to make things a little bit easy. So in channel 1, I've generated a sine wave. I made that sine wave 1 volt in amplitude. And that's because when we start dividing each major division into 10, 1 volt divided by 10 is 0.1, and the math works out pretty easily. So hopefully that'll give you a little bit of a start out. And we've generated another signal, and it's a square wave from channel 2. And once again, we made that 1 volt per division. Both are 1 kilohertz. We're going to keep things simple. We're going to step over to the scope. Now, the things that I'm going to show you in this session are probably the things that you use the most. I hate to say percentages, but 80 or so percent of the time, these are the things that you're going to use all the time. They are the basics, and it might seem like we're going a little bit slow, but there's a lot to learn, especially when you don't have a background in electronics. So first things, over on the right-hand side, we have the interface for channel 1 and channel 2. I can turn either of these displays on or off just by clicking this arrow or this check mark in this box, and I can change all kinds of things like the color and other different things in here. You can experiment with that, and some of those we'll cover, but we're not shooting to cover every single menu option. So let's get rid of the square wave channel for now, and let's just work on the sine wave. And there's some terminology here. We'll hit it as we go along. But the first thing is this little triangle over here on the left side. If I left drag on that, I can move this display up and down on the screen. And also on the left-hand side, which is the voltage axis, you'll see these numbers change. This is the 0 point of the signal. We set this for 1 volt peak to peak. Peak to peak is a term that's used a lot with scopes, and when you set something for peak to peak, you're saying go 1 volt in the positive direction and 1 volt in the negative direction. There is a V peak measurement or explanation for a signal, and that is just setting a voltage to go in one direction, either positive or negative. There's some other signals like RMS and different things like that when you're dealing with sine waves. That's another topic. So we can see this signal. It's pretty nice. And I can move the 0 point wherever I want on this scale. You always see me taking this 0 point and moving it right to a line. I sort of like it in the center. And that is because I have an equal amount up above in the positive direction and an equal amount below in the negative direction. So that's a quick introduction to the voltage. Some other things that you can change. You can see over here is offset and range, and you can see that the range is set for 500 millivolts per division. That means these major divisions here, we talked about that in a previous video. So each of these divisions is going to represent 500 millivolts. If I change that to be 1 volt per division, we see that it goes 1 division in the positive direction and 1 division in the negative direction. Also remember over here on the left-hand side of the screen, when we look at these divisions, they're subdivisions and they go by 10. So 1 volt divided by 10 means that each of these subdivisions is worth 0.1 volt. So first thing we do is we can fool with this range and give us a better view of the signal, make it take up more of the screen, and you can do that however you want. So we can make it actually that it takes up more than what's on the screen, but you have to understand your signal here a little bit. So let's go back to 500 millivolts per division. This triangle over here is something different. Once again, we'll get to that very shortly. And this white triangle here obviously means something. There's stuff all over the screen that means something. So we'll get to all those as we step down through here. This section, the horizontal axis, we said before, goes on time. And you have to understand a little bit about a signal. So if I pick this starting point right here on this waveform, this is sine wave is going to go up, then it's going to come down, and it's going to go down, and it's going to go back to the next starting point, and the wave is going to start over again. We call that a waveform. From here to here, that's one waveform, and the frequency, which is 1 kilohertz, 1 over frequency is the period of the waveform. And you can see that down here, each of these scales, this starts at 0, this goes to 1 millisecond for a major division, 2, 3. So each of the major divisions is equal to 1 millisecond. This 1 kilohertz frequency means that this sine wave completes a cycle, or one waveform, or one cycle of it happens in 1 millisecond. And I can change that too. Now, the time scale works for both signals, both channels of the signal. The voltage range works only for one at a time. So when I go up here and pull this down and say I do 2 milliseconds per division, you can see that now I'm going to get 2 cycles in one block, which is 2 milliseconds. And also, we're really not changing the signal, we're just changing the scale and the division as we go through here. And here I have it up to 200 microseconds per division. I told you electronic people work with small numbers. We're going to live up to that too. So let me change that to 500 microseconds per division. And we notice that we can take a look at the scope and do anything. Now, let's move this 0 point up a little bit. You'll notice when I move it up, the scales change over here. And let's make channel 2 come up on the screen by clicking the checkbox. And you'll notice this has the same 0 volt. We have this signal. It's not it maybe look like a digital waveform, but it's not, because it has a positive voltage and a negative voltage. And those voltages are centered on 0 volts. And since we sent V peak to 1 volt, we have +1 in the minus direction and -1 in the negative direction. And our screen sort of looks like 2 separate waveforms up here at one time. That's called a dual channel scope. If you buy a 4-channel scope, you get 4 of these up at one time. Just to prove to you that the time works for both signals. You can't change them separately, the time base. We switch that over. I'm going to switch that back so we have a good view. The waveform and the cycle time and all that works the same. You'll notice down here I can change this separately to 1 volt per division, separate from this channel. So those functions are there. So if you want to know, let's push the square wave out of the way again. Let's move this sine wave down here a little bit. So it's a pretty classic waveform, so it's fun to fool with and do. So there's something called triggering. I'm going to explain this very quickly, but basically this is the triggering point. I'm going to drag this over to the left of the screen. Remember, the scope is continuously catching this waveform that's repeating over and over. That's what we do for testing and learning. It might not be as much as what's done in troubleshooting, may or may not, but for the most part, you're trying to grab a signal that happens once maybe and not repeating over and over again. But when we train you, it's a lot easier. So this waveform is repeating over and over again. I moved what they call the trigger point over here to the left side of the screen. And I'm going to play, and that's what this white arrow does. And triggering means, when do I start taking the waveform? Well, this arrow adjusts when I do start taking the waveform, and it's called the trigger point, and this is the voltage level for the trigger point. So if I move it up right here, you'll notice this point of the arrow comes right over here to this level of the signal, and if I move it down while you're watching that, you can see that the starting point is changing to adjust the voltage on this waveform to the exact point that this starts, and that's called triggering. And there's a lot of settings for that. We have some of those set up here at the top. We'll get to the triggering points in the near future. Once again, trying to stay with the basics until it's there. So that's another thing that you want to do. By the way, you can change the triggering point to show up anywhere on the thing, and you'll notice now that when I adjust the voltage, the triggering point voltage is right here, and it's changing there as there. I sort of like it over here. Depends what you're troubleshooting on, what you get used to. You can put it anywhere that you want to. Now, another thing that might be interesting is we want to take voltages off of this waveform at certain points to tell what the voltage is and how much time is elapsed. And I clicked on this little cursor button, and it brought this interesting little cursor down so that it can see, even if I'm not on the waveform, it's telling you the voltage level, channel 1 colon 1.014, and this will take the voltage level for you and do it. What it's really doing is picking this point on the graph, coming this direction and reading the voltage for you, and coming this direction and reading the time for you. And the time is relative to the starting point, and the voltage is relative to where the 0 point is and how far up I am. So when you're troubleshooting something, you might want to look at the waveform, but you also might know what specific voltages are at a certain time. So that gets us up. We're being able to adjust what they would call the time base by changing this value, and with our waveform on applied to the input, it looks like we might be changing our waveform, but we're really not. Also too, you can change the display by dragging down here with the left mouse, but you can change the time base by holding the right mouse in and do it. That's an advantage of having a computer user interface. You'll notice that the time base comes to uneven values. We're not sort of used to that as technicians, but with these cursors on here, that's no big deal. If I'm trying to do mental math, having a time base of 1.29 milliseconds per division might get tough for me to do the math in my head. But with the cursors, it's not as big a deal. So I showed you the beginning of using the cursors. I showed you the beginning of some of the time base and the voltage range. Volts per division is usually what technicians call it. Also, when I compare this to a benchtop scope, there's usually knobs to change these, and those knobs alter them in little increments and do it. Here we have pull down menus and we have cursors to be able to do that, which is better. I got to tell you, this interface on the PC is a lot better. It's easier to use if it's well designed in there. So we'll continue on. Remember, what I'm showing you here is what you use most of the time maybe 80% of the time would be my guess. And so these things are important. You have to go in and play with them, and we'll advance these topics as we go along.